Simplify the following expressions. Alright, so let's take a look at these. So negative 4 times 6x plus 5. So we have one negative, which means in the multiplication, which means we're going to have a negative result here. Now we could think of the distributive property, which means we could multiply the negative 4 times the 6 and times the 5, so we'd get negative 24x minus 20. So you could think of it that way. You could also think of it like, well, we have negative 4, that we're adding each of these things negative 4 times. And so you could think of it like, well, it's the same as like negative 1 times 4 times this thing, 6x plus 5. And so 4 times 6x plus 5, well, that's just 6x plus 5 plus 6x plus 5 plus 6x plus 5 plus 6x plus 5. And all of that is times negative 1. So when you simplify that, you get 24x plus 20, all times negative 1, which means you have the negative of each of them, which would lead you here. So a bunch of different ways to think of it. I knew that the result would be negative because of the signs. Part B. X minus 3 minus 12x minus 4. So some ways to think of it are, if you're familiar with this method, which many people might have learned in elementary school, when you're subtracting down, you could do it that way. You could think of it like I'm subtracting down. So I'm taking negative 4 away from negative 3. And when I do that, I end up at 1. I'm taking 12 away from 12x away from 1x, so I get a negative 11x. So you could think of it that way. The more conventional way, I think, of thinking of it is I could rewrite this as x minus 3 plus negative 1 times 12x minus 4. So you notice all I do is I converted the negative into a plus negative 1 to remind me that the negative 1 applies to the whole 12x minus 4, not just to the 12x. Most common mistake, people just subtract the 12x. And so what we're really saying here is x minus 3 minus 12x plus 4, because negative 1 times negative 4 is positive 4. So that simplifies to negative 11x plus 1, just as we found before. For the rational expression, what could I multiply this by in order to have the answer be negative 1? So I'm saying p over q times what equals negative 1? Well, I know it has to be negative, assuming p and q are positive, which I don't know, but it doesn't state anything, so it needs to be negative something or other. But what would I need to multiply it by to get that? Well, we could think of it as inverse operations, so let's maybe go with that. What if I called that x and I want to solve for x? To get p and q away from x, I would multiply both sides by q. So I get px equals negative 1q, or just negative q. Divide both sides by p. And so x is negative q over p. So if you think about this, p over q times q over, or negative q over p, the q's divide out, leaving me just a negative 1. The p's divide out, so I just have negative 1, which makes sense. Now this quantity, q over p, as it relates to p over q, these are known as reciprocal quantities. Reciprocal quantities. You might hear them as the multiplicative inverse. That's true as well, but reciprocal is fine. It means that you flip the top and the bottom, and the interesting thing is when you multiply them, you get 1. So if you want to try to turn something into 1, you multiply it by its reciprocal. So, and this comes in handy in situations like if you have 5/6 x equaling 12. and you want to know, well, what is x? You can multiply, because you want to get this number to be 1 to get 1x. Well, I can multiply by the reciprocal. And so this is 72 fifths is equal to x because these cross each other out.